What's up, Titans? This is Mr. Sturts, and we are on lesson 3.3, function notation. Our essential question is, how can you use a function notation to represent a function? The definition, you have a spot for this in your student journal. Function notation is written as what we call f of x. It's really just another name for y. Okay, so we have y, we call it range. Now we can also call it f of x. It's read as either the value of f at x or f of x. Okay, so get this written down. Our first example here, evaluate f of x equals negative 4x plus 7 when x is both 2 and x is negative 2. So we're going to have two answers here. Okay, so the first one, when x is 2. So all we're going to do is substitute that 2 in for x. So we have negative 4x plus 7. Now we're going to substitute that 2 in for x. So instead of x, now we have 2. So we have negative 4 times 2, which is a negative 8, plus 7. So a negative plus a positive is a negative 1. Okay, so our first answer is f of x equals negative 1. Okay, our second problem here, now we're plugging in a negative 2. So we have f of x equals negative 4. Now instead of x, we're going to plug in that negative 2 and add 7. A negative times a negative is a positive, so we have a positive 8 plus 7 equals 15. Okay, so f of x equals 15. We're just substituting in there. All right, our next part here, we have three parts. Okay, this is let f of t be the outside temperature in Fahrenheit t hours after 6 a.m. Okay, we got to figure out what each of these means. So t hours after 6 a.m. So in this first example for A, it's f of 0. So what that means is it's 0 hours after 6 a.m. So really what this means is at 6 a.m., the temperature is what that equals, is 58 degrees. All right, part B, now instead of 0, we have a 6 in there. So what this means is 6 hours after 6 a.m. So if we do the math there, 6 hours after 6 a.m., so we're now at noon. Okay, let's say at noon, the temperature is n degrees. They don't give us a degree, they give us a variable there. Okay, that's all right. Now, part C, they're telling us it's 3 hours after 6 a.m. So at 9 a.m., the temperature is less than, because we have a less than sign, the temperature less than the, temperature at 9 hours after 6 a.m. So 9 hours after 6 a.m. is actually at 3 p.m. So 3 in the afternoon. Okay, so 3 hours after 6 a.m. is less than 9 hours, the temperature at 9 hours after 6 a.m. All right, moving right along. For h of x equals 2/3 times x minus 5, we need the value of x for which h of x equals a negative 7. Now, it doesn't say x equals negative 7. It says h of x. So remember that h of x is another word for y. So h of x equals 7. We're going to plug in that negative 7 right over here for h of x. Okay, so negative 7 is equal to 2/3 x minus 5. We need the value of x. Okay, so we're solving for x. Get x by itself. So first thing we're going to do is add 5 to both sides. Okay, and negative 7 plus 5. Different sign, subtract. So keep the sign of the larger number. We have a negative 2 equals 2/3 x. Uh-oh, we got a fraction now. Okay, now the operation going on between that fraction and the variable is multiplication, so we're going to do the opposite. We're going to actually divide by a 2/3 on both sides. Now, when we divide by a fraction, we say it's the same as multiplying by the reciprocal, or copy dot flip. So we are going to multiply by the reciprocal, or that fraction flipped on both sides. So instead of dividing by 2/3, we're actually multiplying by 3/2. Okay, and when we do that, negative 2 is the same as negative 2 over 1. Okay, now this allows the 2/3 and the 3/2, those cancel each other out. So all we're left with is an x. equals, if we cross reduce here, 2 and 2, they each go in, 2 goes into 2 one time. So if we multiply across the top, 3 times a negative 1 is a negative 3. Negative 3 over 1 times 1 is a 1. So we can just leave it as a negative 3. And that's our final answer. That's x. All right, a graph. Now, when we graph in here, we're going to make an input-output table. Okay, so on your graph here, or in your journal, make an x and a y. Now, for today, we're going to do 5 points. Okay, we're going to do negative 2, we're going to do negative 1, we're going to do 0, 1, and 2. Now, this is our input. These are our x's. Our output is what happens when you plug it into the function. So if we plug in a negative 2, we have 2 times a negative 2 plus 5. We're substituting in for x. So we have negative 4 plus 5. We get a 1. Okay, now 2 times a negative 1. We're just going to take turns plugging each of these in for x. That equals a 3. Okay, so we had a 1, we had a 3. Now if we plug in 0, 2 times 0 is 0. Anything times 0 is 0. Plus 5, we're getting a 5. We see a pattern going here. 1, 3, 5. This one should go up by 2 as well. 2 times 1 is 2. Plus 5, we get a 7. And our last one, 2 times 2 is 4. Plus 5, we get a 9. Okay, notice how those each go up by 2. These each go up by 1, so we know from last chapter it's going to be a linear function. Okay, so let's go ahead and graph it real quick. Okay, if we graph this negative 2, let's put a couple tick marks in here. Okay, negative 2, 1. So we're going to go left 2, up 1. We're going to go left 1, up 3. We're going to stay at 0 and go up 5. We're going to go over 1 and up 7. And one more. We're going to go up to 9 over 2. Okay, now we're not going to connect those. We're going to leave it just like that. But notice it's a linear function. It's in a line. All right, and last slide here. We got a word problem. Okay, this graph shows the number of miles a helicopter is from its destination after X hours on its first flight. Okay, so that's a graph of its first flight. On its second flight, the helicopter travels 50 miles farther, but it increases its speed by 25 miles an hour. So the function that they give us here, f of x equals 350 minus 125x. That represents the second flight. Okay, the graph is the first flight, that function is the second flight, where f of x is the number of miles the helicopter is from its destination after x hours. Okay, what they want to know is which flight takes less time. So what we need to do is first, we need to graph our second flight. So let's make our input-output table again. Okay, so we need an x and a y. Now this time it says x is hours. So in this case we're not going to do any negatives. We're going to start at 0 because you don't have negative hours. Okay, so we're going to start at 0, and let's just go up to 3. Okay, so on our graph here we're going to plug in 0 to our function. Our function's right here. It's 350 minus 125x. Okay, and we're going to take turns plugging each x in and substitute it in right there. So the first one, 350 minus 125 times 0. Okay, so in that case, anything times 0 is 0. So we're left with a 350. I'm going to have to squeeze these in there. Next one, we're going to plug in a 1. Okay, so 350 minus 125 times 1. Okay, so in that case, we're going to get 225. Okay, if we keep doing this, we're going to plug in a 2, we get 100. We're going to plug in a 3, we get a negative 25. Now, on our graph, okay, we need to compare the two graphs. Now, this would be a little better if we had some graph paper. Okay, but in this case, actually, I'm going to move this over a little bit. Okay, on our graph here, we need to plot our points. So, x, remember, that's our x-axis. Okay, our x, I actually put y instead of f of x, which is okay. Okay, that's there. We can switch them out. Okay, but x is 0. Okay, so let's make some tick marks here. 0, 1, 2, 3. So we got a 1, a 2, and a 3. Okay, we have 0 down here. Now let's go up by 50 because that's what the other graph did. Okay, so we're going to count up by 50s and we're going to plot our points. So we have 100 here. We have 200 up here. So we're going 0 and up 350. So we need one more up here. Okay, this is a little messy. Like I said, it's easier on graph paper. Now over 1 up 225. Over 2 up 100. And over 3. Now it does go negative, but in this case the graph, it doesn't make any sense to have negative hours like we said, or negative distance. Okay, so we're just going to assume that it's kind of down here somewhere. So when we draw our line through these points, we're going to actually stop on the positive. Now let's compare the two. Okay, if we compare, look up here. When x is 0, when x is 3 at 3 hours, our y is 0. Okay, now over here our x is a little less than 3, and our y is going to be a little less. Okay, so what that means is, since it took less time, that second flight will take less time. Okay, so sooner we went a smaller distance. Okay, if we skip over this next, I'm going to go on to your practice now. So now that you've taken these notes, turn to page 94 and finish these 5 problems. Okay, we'll check these tomorrow in class. Thanks for paying attention. We will see everyone tomorrow. Have a great rest of your night.